Okay, then maybe let's start. Welcome to this workshop or webinar, I don't know how to call it really. So I had to move to a laptop, so I rather said the speaking language Portuguese, okay. My screen is a little bit small, so please use the chat or unmute and just interrupt if there is anything wrong, if anything going wrong, or you can also ask questions anytime. That's fine. Because I cannot leave the chat fully open. So maybe it's better if you unmute yourself and just interrupt. Let's go. So great pleasure to be here to be presenting this webinar about building figures with Inkscape. I saw that there is another Inkscape session just after this one by Jan Brocher, which is very good because it makes sense to give those two together. I will maybe not focus on Inkscape itself, but more on a set of Inkscape extensions that I wrote with Martin Owens, with an Inkscape developer. And this set of extensions is designed to enable creation of figure content that also carries the code to generate the view that you are including in the figure. So this is not extremely new. This is not maybe not the sexiest session that you will see in during this conference, but I think it's still useful. It's something that we started in 2021, actually, and we made it a little bit better over those 2 years period. So I'm going to show you this. Just to start, I want to introduce myself. So yes, the presentation title will be creating a figure content with Inkscape, reproducible figure content with Inkscape using third-party panel providers based on ImageJ, R, or Python. That's from the title. So my bio, briefly, I'm a facility manager, optical microscopy and bioimage analyst in a CNRS lab in France. It's a plant biology lab. It's called the IBMP. It's in Strasbourg, France. So mostly I do confocal microscopy and a lot of image analysis, and this is what I like most. We also have electron microscopy, but standard light and confocal microscopy is what we do most. I like to start with this slide. The reason behind this is that it just illustrates that we are very busy in the lab. This is not a picture that I took, but we don't have enough time to do everything that we need to do. So from a very early stage, I tried to focus my work on the sometimes very specific items, but where I can have my colleagues save some time, because they need to master a lot of different techniques. They need to have a microscopy, bioinformatics, proteomics, whatever. A lot of different techniques to master and a lot of technologies, a lot of software. So I think every little help that you can bring can make a big difference. This is like my overall goal that I set myself. And it so far it aligns with my employers. So this is good for me. So, and I since a very long time, over 10 or 15 years, I've been playing with creating figure content and creating tools to make figure creation easier or more reproducible or more, to facilitate using different angles, different approaches to facilitate scientific figure creation. One of the first ImageJ macro set that I did was called Magic Montage. It's now built into ImageJ. When you go to the additional tools here, it's called Magic Montage, and you can from an image stack, you can easily create a simple montage. Okay, this is fun to use. But not so convenient because every panel should be the same size exactly. But still it's playful because you can rearrange them very easily. And then you have a few shortcuts to make a channel overlays, to make crops, some very specific but efficient tools. But it was some told me that it's a toy basically. So then after that, I wanted to go further and to address the problem of traceability of figure content. And this is where I created, together with Eda Zink, student of mine, we created the FigureJ plugin. FigureJ was a simple ImageJ plugin based on tree maps, considering that any scientific figure can to some extent be mapped into such a tree map structure with panels showing content. And by setting this and making this very clear that it should fit inside the tree map, which is kind of an assumption, which is sometimes wrong, but you can make this assumption. If you make it, then it makes it very easy to fill those panels. So this is the idea behind the FigureJ figure creation assistant, if you want. It was based on the idea that each figure panel is a view inside a dataset. So this view should allow you to present a certain view of a dataset. So by creating just a selection tool that matches the panel size and the ratio, aspect ratio exactly, this makes it extremely easy to fill this panel with content, with any kind of content, image content that is supported by bioformats. And because you stay in the same software and you are inside ImageJ that reads many formats through bioformats, you can also take advantage of this, and you can track whatever you do while you are creating the figure. So this adds to FigureJ some traceability of the image processing that is done during figure creation. I'm not talking about this plugin today, but just behind the scenes, there is a macro recorder that is triggered every time you open an image automatically, and that will record everything that you do, so that when you push the content, the view into the panel, whatever you have done between the time you open the image and the time you push it to the figure, this is also recorded and attached as a metadata to the figure. So to some extent, those figures are already quite reproducible, because you have both the original data set, then the view that you select inside this data set, and you have the steps that are automatically recorded, the steps you took while you were constructing your figure. This was, I told you, 10 years ago already. And quickly after FigureJ, there were a few very good, excellent other software that were published or spread to assist with figure creation. And this is not like they don't make exactly the same. They don't achieve the same as figure J. They do some things much better, something not as good as figure J. Yeah, that's not the problem. But to me, it shows that the figure creation process is really a central point and a very interesting point for people to work on, because everybody needs to build the figures, and there is still a lot of new approaches to take to facilitate figure creation. Maybe I just have a quick look if there is something in the chat. No, perfect. So I'm listing them here: Omiro Figure, Scientific, EasyFig, Quick Figures, and the set of ImageJ or Fiji plugins by Jan, who is in the audience, and we will give the next talk that help with embedding image content in SVG documents, which is, by the way, exactly what I'm going to show you today as well, with slightly different approach. Okay, so that was figure J, and so with a few tools that would assist with laying out your figure. For example, you could easily adjust the panel size as long as they would fit to this hole. You always had a hole space, and that you needed to cut into several parts, like a full space and then daughter or parts, like a hierarchy of panels. So, but this computer can do this very easily and efficiently. So it's a good assistant, assistance to perform those tasks. Of course, the selection of the area, interesting area, was crucial and very good stuff. This one I can skip. I added a few tricks to make it even easier, like you can drag and drop inside the panels, or you can exchange panel content by dragging and dropping with this smaller spring tool, which is fun to use, but saves just a few seconds. And then a good part of the figures, classical figures, scientific figures, include other stuff. There are images, but there are also other stuff, like which I called decorations. Okay, but like additional text, scale bars, panel labels, arrows, maybe many other stuff that you want to see, you want to use to build a very nice figure. So to some extent, figure J did achieve a few things to make figure creation easier. And if you do exactly this kind of figure, like image-only montage of microscopy images with a few labels, scale bars, panel labels, then I think it's a very efficient plugin. Plus, you get the link to the original data, and you get the traceability of what was done during figure creation. So I was quite happy with that at that time. But of course, my colleagues, you, even myself, we don't want to stick with figures as simple as this one. Okay, if you maybe 10 years ago, maybe 20 years ago, but now if you open any good article, you will see that any figure is much more complex than that, because of the many techniques that are required to publish a good article. You have to mix a different kind of data, not just images. I was stuck with just microscopy images, but nowadays any figure, scientific figure, will include tables, plots, special visualization, from the bioinformatics facility, whatever, from R, from Python, from whatever. So you want to mix a lot of different content from different sources. And this was, I did build a hack into FigureJ to do this, but it was not convenient at all. It was not, I ended even to hide it inside the FigureJ user interface because it would bring more problems than solutions. And these were the main criticisms that I got about FigureJ. I mean, friendly, but still. Reproducibility was there, but limited to the steps you took during figure creation exactly. But the main critic was that the layout was easy but not flexible enough. See, very easy to do a simple montage like this, but it's not flexible enough because you don't want only images. You want to maybe to have a little more space between images. One of them you want to move aside, then inside this area you want to put some text, whatever you. I mean, in every lab, every person, every researcher, he has his own style that he uses to. It's part of the lab identity to create figures that have a given style, and this you could not achieve by just sticking to a simple montage. So this is why, and now I'm coming to Inkscape proper. I decided to start again a new system, not to upgrade FigureJ because it was too closed, too set in stone. I wanted to use a proper layout software. So you have a few choices to do this. You have Adobe Illustrator. You could use, why not PowerPoint? Why not? But it has its big limitations. But you could use basically anything, maybe, I don't know, Word or OpenOffice, even maybe Google Slides to assemble figures. But I decided for Inkscape. So Inkscape is a why? Because it's also a free and open source software, the sort of software that I like, because you can like recommend it to anybody and then they can install it, use it for free. And but mostly it's open source software. So and like community driven software, which means that the software is being developed, but mostly by contributions, ideas, or bug reports, or directions that are inspired by the users. So I find this really nice, and it's the same kind of philosophy that were in ImageJ that I used a lot. So this is why I choose Inkscape. And also I had a first approach, looked a little bit into it. And then I found Martin Owens, who is an Inkscape developer, one of the very active, maybe the main, I don't know, one of the main Inkscape developers. And he's also a freelance developer that I could basically hire for a few hours to achieve what I had in mind. And this is cool. This is cool with the open source software. You have an idea, you have a chance. There is a chance that you can you can have this idea built inside or in an extension for a given software, which is unfortunately not possible with all proprietary software. Just having a look at the chat just in case. Okay. Perfect. So it's a free vector graphics editor, multi-platform, free open source. What it does, it's historically, it was built to comply with some kind of standard, which is the SVG standard. And SVG is a language, a code to describe like any document content. Like you have hierarchy of tags, just like in XML, but it's called SVG. It's like a special sort of XML. And tags, they will be nested in one another. And each object can have attributes. So, and using this very flexible approach, you can specify every item that you would see or place in a page. Okay, so this is very interesting for many different reasons, but mostly because to me, because it's a little bit open. It's not just that you have your document and you don't know how this is built, how this is done. It's very transparent in that you can almost read the SVG and understand how the elements are placed because they are simply like in a text-based file placed with attributes like position, size, color, whatever, that you can read in plain text, plain English text. Of course, you can also have images. One of the elements that you can have are images. So this is the stuff. SVG defines vector-based graphics in XML format. Just to remind you of what it is exactly. But this also means that it's because it's simple language. I like this. I like programming. So I thought that maybe I can like hack into this simple language to include there stuff that were interesting in terms of building scientific figures. So I designed the concept of those extensions that will be encoded in SVG and carry the code to draw themselves. Let me explain. This is the general concept. Sorry. Maybe I can make it bigger. I should have done this from the start. It's a little bit bigger. It's better like this. Yes. So the workflow is this one. You have a document, empty document. Every figure starts with an empty page. And then you can draw an area. And this is like the figure panel, a figure panel. And this panel, you can name it, give it an ID. But you can, there was already a description field in the SVG that was, to my knowledge, barely used. And I thought this was the perfect place to include the code that will be run to render the panel content. This is as simple as that. So this is exactly what we've done with the help of Martin Owens. So you just draw a panel, then add some code, and then you apply the code. It will be run by a third-party software. I would say any scriptable software, but in this example today, with ImageJ, R or Python, but there are more. And then, for example, R will compute and render the histogram using this. You see, this is a simple hist command from R. So R will run this, grab the result image, and insert it at the same exact location where you drew the original panel. So this makes it super easy. You end up with a new panel in your figure, but that is made with code, which has a lot of advantages, but mostly it's reproducible. You can share the code, you can reuse, modify the code, change it for another usage, whatever. So this was the general concept: drawing a panel, adding some code, render it, include in the document. How does this work exactly? Because I told you about the SVG exactly. So position and size, those are the attributes of the panel. Position and size inside your figure. Then you have the code. This is a processing example. So what the extension does, it mixes the properties of the panel and then the code needed to render it. Then it injects this into a script template so that the template has the right values for the position, size, and the code. Then a third-party software renders it. In this case, it's processing. And after that, the result of the script is included in the document. And this fills your figure panel. Was there a question? I heard someone asking maybe a question. No. Okay. So this simple concept of mixing SVG item properties and code, and then running it with a third-party software and including the result in the document, this can be applied to many different software that address different data sources. So my first love, ImageJ, my go-to software. I did it for ImageJ macros. So you can write an ImageJ macro, and then you can render it and include directly the result of this macro inside the document. Because it's that easy, you can reuse also the same code twice in the same figure with just a slight modification. And then you can make a little bit more complex figures like this with 2 images that are fully reproducible, because you know the source data, you know what has been done. But also it's very flexible because it's a full Inkscape document with the layout that you want. So for example, those dashes here, those are simple Inkscape object. This is something very important that I want to say. I'm all for the reproducibility of figure content, but you can never achieve the full reproducibility. There's someone in the chat. I'm making just a small pause to answer in the chat. What languages are supported? R, Java, MATLAB, no. So far, R, Python, and ImageJ macros, and PyMol and processing Java. So 5 languages. You're welcome. But if you want to add MATLAB, it's so easy because I'm not a MATLAB user, but it could be so easy to do because MATLAB is fully scriptable. So you could basically paste a MATLAB script, and then you just need to write a small wrapper that calls MATLAB against this script, and then grabs the results, pushes to Inkscape. I can show you exactly how to do it if you want. Okay, let's go back. So this is an example with R. R code is here, and this is the result of R code, a 4-panel, a single Inkscape panel, but that is made of 4 R panels arranged together by R. This is a PyMol example. PyMol is a molecule drawing, 3D molecule drawing software that has its own language, PyMol scripts. So you can simply paste PyMol script here, and then you can render views, special views of your molecules. If you want a different view, just set the view to something different, and you will get the same molecule at almost no cost within the figure. Maybe I need to mute someone. Let's see if I can find out who. Maybe Lily, I'm going to mute you. Sorry. If you want to ask something, just use the chat, please. So this is the processing example. So processing is a drawing with code for artists, or learning, teaching code to artists, or teaching art to scientists, to coders, kind of software. So you can use a simple Java dialect to draw inside your Inkscape figures. This is just another example. I know that not many of you use processing probably. Okay. 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 Maybe I can keep this for the last part of my talk and provide you with a small demo. Of course, I will leave my slides, but this is recorded, so you will get them anyway. But if anybody wants the slides, I can provide the links. That's fine. And now I'm going to change the share and just do a live demo for that. Just give me a minute. I need to change the share and share basically the whole desktop. Are there already some questions that I can could answer now? Don't keep them for the end, because we can maybe answer those right now. If there aren't, I'm going to share the whole screen. That's it. Good. So I can hide this. This is my browser. You don't want to see this. And this is the Inkscape. So I guess maybe Jan, maybe you're going to maybe go more in depth about Inkscape itself. So I'm not giving a lot of tricks about Inkscape proper. Just now, oh yes, chat. Thank you. Yes, I will a little. Cool. Cool. I'm not an Inkscape expert anyway, so I will gladly listen to your advice as well. Thank you, Jan. But basically what was of interest to me is that you can handle pages, which is still a useful concept, maybe less and less, but still useful, even if SVG is an infinite space. And so a page that you see in an SVG document is just a part of the larger infinite space, SVG space. So you have pages and you have all kinds of objects that you want to see or use to create figure, shapes, arrows, lines, Bezier lines, text, colors, gradients. Those are really important. Since I started this project, there were a lot of improvements. For example, you have multi-page. Inkscape used to be a single page software. Now you can have multi-pages. So you can basically, you have a page tool and you can just create a new pages like this. This is a new page that do not need to be the same size, whatever. You can, of course, set the predefined sizes, but you don't need to. And then you can move them around, reorder, name them, everything that is necessary if you want a multi-page document. This is one stuff that was important to me. You have groups of objects organized in layers and groups. So this is very useful to handle the priorities like overlays of stuff. You have a very nice alignment capabilities, either through classical buttons like this, but you have also on canvas alignment guides that are really among the best that you can find in any other software. Here you have, for example, all the items you can align on. You can align basically on all items. This is really useful when you want to perfectly align your figures, which you want to do, but not as strictly as in ImageJ. But enough with Inkscape, and you can copy paste, select styles, colors, whatever. What is really interesting for me was this object properties dialog. So each object that you would draw on your canvas, for example, a rectangle, is an object, and each object has some properties. And the very interesting one for me was this one, the description, because this is where this is the area that I use to write the code that is associated with the document. So you need to save the document so that it knows where it is. And then after it's saved, you can you can immediately start typing some code. So for example, ImageJ code, simplest example, run blobs. This will open the blobs image. Okay. Just consider this as a text editor, programmer's text editor. And then you need to set this, press the set button, and then you can fire the extension. So the extensions, I will show you this just after that, how to install them, everything, but they will end in this submenu, extensions, figure, and then you will get all of these if you install them properly. I will show you the installation procedure, and there is also a document that I'm sharing with you later with all the details for installing this. So for example, you choose the ImageJ macro panel because this is ImageJ language, and you can simply apply. So if you apply this code to this panel, it will fill this area with the result of this macro. So you don't see the ImageJ graphical user interface. This is called in headless or batch mode, headless mode, without starting the graphical user interface. But the result image is retrieved by the extension and pushed inside your document chat. Third-party plugin engine are Python generate bitmap images on the fly, cache, explicit name, which are then included as SVG object. Exactly. Can you choose the DPI value? Yes. Yes, you can. But in different ways when we consider different software. For example, for images, okay, let me put it this way. The SVG document itself has some default resolution that you can set in the document properties. But then this area here, you define the given dimension when you draw your rectangle, and then you put image content. So this image has a certain resolution, not any resolution. You cannot set the resolution of the blob image. What you need to set is the interpolation method, because you want to adapt a given image with a given number of pixels to another dimension. So this is done, and this is one of the attributes of the image object in SVG. So if I go back here you have the, so I need to select it. Here you have the mode of image rendering. So auto is like with interpolation. If you want to have it without interpolation, which in general I think we want in microscopy, unless it's a very special use case, but usually we want non-interpolated pixels. So you would choose pixelated, and then if you look at it closer, you have the original pixel size from the blobs image. So this shows exactly the original data, but enlarged, which means interpolated using the nearest neighbor interpolation method. If you want a method with interpolation, you can choose optimized quality, and this will make it, because this semantics is from the arts sector. So if you choose optimized quality, then it will be smoothed. Probably it's like a cubic interpolation in image. See the difference? I don't know if this shows very nicely through Zoom, but this is how you would choose for images from ImageJ. Then for DPI, it's not really exactly, yes. Okay, I totally agree. Thank you, Jan. But then for example, for Python, Matplotlib or R scripts, then you can choose DPIs exactly in the extensions options. Let me add a different rectangle and then use the R script panel. Yeah, or maybe why not the Matplotlib panel? So it's called Matplotlib, but it's a Python basically with a Matplotlib object that is used in the end to display the last current image. So you need to point, just commenting on the setup a little bit. You need to point the extension to a given Python environment. This is the best case. You could, if you have a single environment, then use this. But if you have multiple, like Conda environments or whatever, then you can point to this specific environment that can run the script, and then you can set the image resolution. And this value is used inside the Python template to render the panel, with some magic to have a good-looking fonts, that kind of stuff. Okay, so now you have and also a default font size that is see, so you get very high quality Python plots here included. In this case, just notice that I did not add any code, and then suddenly there is this code. How comes? This is because when the code is empty, then it will generate a sample code that you can start with, or just to try the extensions. This is just a template, an example template that is included with the extensions. So if you would like to change this, you can. If you want to reduce with the same, let's choose the same graph here and make it. You mentioned, I think, 72 DPIs. So let's apply. Okay, you see? Can you see the difference? Can you see the difference? Now it's 72 DPIs. See? Let's make it 300 DPIs. So yes, you the answer to the chat is yes, you can. Reapply with, see, exactly the same font size, and this is this was a a very good enhancement to these extensions that were suggested by Tim Oliver in Basel. He said, why don't you just use the image resolution in DPIs instead of I used to have a base resolution and then use a multiplying factor, which was totally weird. I don't know why I did that, but. Question from Jan, is the plot labels editable SVG text? No. I need to answer this properly. So far, I choose to have a bitmap output for every extension. But I know, of course, that both Matplotlib and R, they are capable of outputting SVG. So you could totally have a SVG output and then include this SVG inside the Inkscape SVG document. So then you would have a fully editable SVG. Why did I not do it? Because this has its limit as well. Because a SVG document is very good if you have a few vectors, like even many vectors, but not a huge number of vectors. If you have a plot with, for example, a scatter plot with 1 million points, then encoding this in SVG is crazy. You get a SVG part just for this plot that whose size will be simply huge. So this is why so far I decided just to stick with the PNG bitmap output. Yeah, it makes sense, but it would definitely make sense to sometimes have the option to use a full SVG. This is very easy. We've done this with Martin. because in embedding SVG inside SVG is even easier than embedding images. So maybe we will put this as an option, because each extension has options, the dialog that you can that we could enrich with options that would make sense. Oh, I'm just looking at the time because I like to talk. So I have prepared the document that I'm also going to share with you with many examples that you can reuse and study maybe later. So it's a 3-page document with simple use cases. Of course, there's the ImageJ example, there's a Matplotlib example, there's a processing example. You can grab images from the web. So for example, a Twitter image displayed with a Matplotlib script. So if you want to, and this is the good point, because now, and this is this, I almost forgot, but this is the core of this presentation. Now you have a figure, but you also have the code that generates those panels. So if you submit this, or if you want to reuse this, you can go back to the code and to the original data. Let me show you. You just have to click here, select this, and this is the code for grabbing the image and maybe displaying in like this, or with a different, for example, if I want to restore the axis, I can just command this and do it again. See, the axis will reappear in this plot, hopefully. Usually the demo is always a mess. But yeah, that's it. Now I have the same image, but with the axis, just by commenting this. Can you share the link for this figure? Yes, I was planning to do this exactly. Maybe just at the end, I will. It's already on the website. I just have to find the link and paste it in. I will paste it in the chat, of course. This is the idea behind this presentation. So this is the example with PyMol. And you see, you retain the full flexibility. You have your PyMol object, but this, you don't want to script this, because this you want to place exactly where you want. You have to retain flexibility for this. But for the molecule, it's there. And maybe if you want to rotate a little bit more, you should just add 10 degrees to this rotation and do it again. So now I'm not even going to the extensions menu, because I added shortcuts. So I just pressing one shortcut, and then I can slightly rotate this. If I want 2 different angles, it's even easier. You just copy this, paste this. Now I have 2 of them. And then I will, for the new one, I will rotate it 60 degrees, set, and regenerate by pressing the PyMol shortcut on my keyboard, which you cannot see, but trust me, I just pressed the one thing. And now you have the same molecule, 2 different views, without writing or by just editing code. You don't have to find this code again. You don't have to go back to whatever. It's kind of a notebook. It's a figure, but it has the code to generate itself. This is grabbing simple chemical molecule view from PubChem. So just change the compound ID, and then you get a different molecule. And it's a Python code in this case, set. So I just change it to a different compound and regenerate pressing the Python shortcut. Of course, it takes a few seconds, but it's not a lot of time compared to, I mean, recreating this exact view, this exact kind of view. This is a what it's called, Seaborn library for Python. They make very good renderings, and basically you can run any Seaborn example inside this using the Python molecule, but you can also think of more complex stuff. I have 5 more minutes, so I have to be short. I don't want to get over time. So this, for example, is an image that is taken from the cell protein atlas, from Anna Clem's macro course. So it's not even in my computer. It will be grabbed from the internet and then displayed in my figure. This one is on GitHub. This one is a QR code created by the ImageJ. I saw recently very nice figures with 1 QR code per data, and this I thought was fantastic. And these are more examples using R. Everything that would work in RStudio, you can also make it work with this extension. That's it. I don't want to go over time, and maybe keep a few minutes for questions. I had a very crazy example with ChatGPT because you see the SVG is code, so you can ask ChatGPT to generate code. So I asked ChatGPT to create the SVG code for a scientific poster with detailed sections, and it would do it. Okay, so I'm not showing it to you. You can try it yourself, and you can just copy paste the result of ChatGPT inside the Inkscape, and you will have the base layout of your poster. This is, I think, crazy. But then you can concentrate on feeding those panels with reproducible content using this system. There are a few more. I have a few videos that you can look at if you got interested in this, because you can also link the panels and then have a sort of workflows. And the last thing that I want to say is that any piece of SVG can be considered a clip art, and you can have a clip art library with figure elements that carry code, and you can push them to a clip art online library so that you can facilitate reusing the same graphical elements, for example, for your lab or for your institute. I'm stopping now, and I leave a few minutes for questions. If there are any questions, please unmute yourself or use the chat if you prefer. Anyway, thank you very much for attending this, and let me know. Do not hesitate if you have any question now. The link to the figure, yes. So this I will do it right now. It's here. It's in example SVG. It's not. Nice. Oh, it's here. It's this one.
Jerome, just to mention that shortly, what you told me, it's potentially you should mention that this is mainly working just with ImageJ, not with Fiji, right?
Oh, yes, yes, exactly. So far, it works very nicely with ImageJ. Some people added working with Fiji as well, but the problem, in my opinion, is that Fiji takes a long time to start, and then it's like a little bit boring when you wait for your input. And I also add Fiji has a tendency of outputting a lot of errors or warnings, and this so far spoils my the way that I communicate from Inkscape to the third-party software. If there are a lot of warnings, this spoils this pipeline of grabbing back the data. But I'm confident that it can work with Fiji soonish. Is there an Inkscape plugin to insert charges? Not yet, not yet. Alex, excellent question. Actually I did this yesterday because I saw Robert's generative image analysis stuff, and I thought I must also include some ChatGPT stuff. There is not. You cannot paste SVG. You have to save it somewhere, and then yeah. Then import, save and import. But having importing what text, what SVG text is in the clipboard is a super good idea. And I will suggest this to Martin. If he's not totally against, maybe it's a simple enough feature, and maybe it can make it to the 1.3.1 release. I just want to advertise also for, oh yes, excellent question. Where do we find those extensions? I didn't have the time to show you. So it's in GitLab. Dr. Mo, this is Martin Owens. This is his GitLab account. And so if you go to, you still can see my screen. In his personal projects, you have the Inkscape ImageJ panel. This is what it's called. If you click here. So we have the repository for those extensions there. You can just download every extension using the download button in GitLab. Those are the files, and you need to put them in the extensions folder. I have 1 more minute. I can show this to you. Inkscape preferences. Then in preferences, you go to user extensions here. There's a button to open this folder directly. Okay. And this is where you need to copy the GitLab, what's on GitLab. You need to copy them here. And then restart Inkscape. Last, but not least, you need to configure them. So you need to point a given extension to a given exe file or that will be used for the third-party software. Just one example for, I did show it already to you for Python here. In setup, you need to point Inkscape to where your Python is. And this is true for every other stuff, for R, for Python, for processing, for ImageJ. But there are examples for this in the installation document that I will share with you. There is detailed instructions, but unfortunately, I'm not gonna lie, it will take you maybe 1 or 2 hours just to have it set up, and then it works, and then you will save some time. But then you have to invest maybe a few hours. Now I'm over time. We have to stop because the next talk is going to be nice by Jan. Thank you very much for attending. Do I have to? Is the session reused, or do we all leave? I see people leaving, so maybe I will also leave and join the other session. Laure, hi Laure. You see that it was a bit of a repetition that what I gave in Basel, but. Okay, see you. See you, bye. Thank you. Thank you very much. If you have any problem, just contact me.